All right, this video is about finding the area of any regular polygon. So a regular polygon, a square, an equilateral triangle, a regular pentagon, a regular hexagon, a regular octagon. You'll recall all have equal sides and equal angles. So a square, all 90-degree angles, equal sides. Triangle, 60-degree angles, all equal sides. A regular pentagon, all 72-degree angles, I believe. I'll have to look it up. Maybe it's 108. I'm thinking exterior angles. You don't have to know that too much. I mean, remember to find the measure of an interior angle. It's 180 times parentheses the number of sides minus 2. Okay, so if you have a pentagon, 180 times 5 minus 2. That's 3 times 180, okay, which is 540. Okay, 540 then divided by 5 tells us that an interior angle equals 108. That'll be important as we move on in this, where you have to use Pythagorean theorem, 30, 60, 90 especially, and 45, 45, 90. Okay, but there's this one basic equation, so that's the good news. So it's 1/2 times what's called the apothem. The apothem is the distance, and it's always a perpendicular from the side, the distance from the center of the polygon to the side. Okay, so here I have a regular pentagon, here is the center, and then the apothem goes directly to any of these sides. It's all going to be equal. All right, and then it's times the perimeter, P. Okay, all right, so here I just have a basic problem where you're given all of the information. You're given the apothem is equal to 7. The perimeter we do not know, but we know that it's a pentagon, and we know one side is equal to 12. Okay, the perimeter is the distance around, so 12 times 5 is the perimeter. The perimeter equals 60. So then I just plug in. If I know the apothem is 7, 1/2 times 7 times the perimeter, which is 60, the area is going to equal 210. Okay? The tricky thing is you're usually going to be given, you know, the apothem or one side, okay, and then you got to work from that. If you're given the sides, then the perimeter is easy to find, okay? If you're given the apothem, obviously then you got to do some work usually to find the perimeter. All right, so here's a sample problem that you might encounter. This is a regular hexagon with 6 sides. All right, and this is what we're given. Okay, so it's important, don't make the mistake of thinking the apothem is 17. The apothem is given to you, but the apothem is 15. That is really important. We don't know the length of the sides. Okay, well, I know that 17 is the hypotenuse of this triangle here. And I know that the apothem is one side of that right triangle. And then this value x, which is going to be half of the length of a side, is the other side of the right triangle. So Pythagorean theorem, the most important thing that you'll learn this year. I just set up the triangle here. X squared plus 15 squared equals 17 squared. I do the math, I get x squared equals 64 and x equals 8. All right, that's a Pythagorean triple, 8, 15, 17. All right, why is that helpful, getting the 8? Well, that x is half of the distance of the side. So it's important to remember the apothem is going to bisect one of the sides. So I double that value of x, and that tells me that a side is equal to 16. Once I have the apothem and the side, then I just do the calculation. So the perimeter is going to be 6 times the side. Okay. Well, why is it 6? Well, this is a hexagon, which is 6 sides. Here we multiplied times 5 because that was a pentagon, which is 5 sides. If it's an octagon, you multiply by 8. Well, this is a hexagon, so 6 times 16 equals 96. All right, and so that's our perimeter, and then I can just plug into the problem. All right, 1/2 times 15 times 96 equals 720. One of the things that I like to do just for kicks is if I calculated the area of this triangle here, all right, so this value is 8, this value is 15, okay, well, the area of that triangle will be 1/2 times 8 times 15, which is 60. Well, this is a kind of a way to double check. If the area of this triangle is 60, how many, triangles like this am I going to have? All right, so this triangle here, I would end up having, it turns out, 12 triangles going around. 12 times 60 equals 720. Okay. Alrighty, so that's, you don't have to do that. It's just, I like to do it as a way to check my work. Okay. That's the second hardest type of problem. The really tricky ones that you'll encounter for the homework will be using the 30, 60, 90, 45 degree. All right, so this is problem number 18 from the homework. Let me center this up. I had to move my classroom because it's so dark today. I usually use the natural lighting by my windows, but it's all cloudy and miserable, so you wouldn't be able to see anything. All right, hopefully that's good enough to see. All right, so here I have this triangle. Well, you might say to yourself, well, the area of a triangle is 1/2 base times height. Well, we're not given a base, and we're given a base of 8, but we're not given a height. Okay, so what I can do here is, here's my apothem. The apothem from the side is unknown. Okay, well, we know the apothem bisects the side. Well, if the side is 8, then this portion of this triangle here is 4. Okay, and then we don't know the hypotenuse, and we don't have to figure out the hypotenuse. We know that it is a right triangle, okay, and the longer side, or opposite 60, is the shorter side, or opposite 30, times the square root of 3. Well, what do we know here? Okay, well, this is opposite 60. Okay, so we know the longer side. Okay, so the longer side is 4. So what does the shorter side equal? The shorter side is going to be our apothem, or opposite 30. So we're going to divide both sides by the square root of 3. So the apothem equals 4 divided by the square root of 3. All right, so this is because, well, how do we know this is 30, 60, 90? Well, because it's an equilateral triangle, we go from the apothem straight up. It bisects this 60 degrees into a 30-degree angle here. And then this must be a 60-degree angle because that's the hypotenuse. So the apothem equals 4 over the square root of 3 divided by 3 when I simplify that. You'll recall we simplify it by multiplying numerator and denominator by the square root of 3. I get 4 square roots of 3 over 3. So what is the perimeter equal? Well, we know the side, so that's the easy part. The side is 8 times 3, the perimeter is 24. Now we know the apothem is 4 square roots of 3 over 3. The area equals 1/2 4 square roots of 3 over 3 times 24. the area, when we simplify that all out, equals 16 square roots of 3. Again, just for kicks, I like to, we can calculate, we know this apothem here is 4 square roots of 3 over 3. This side is 4, 1/2, 4 times 4 square roots of 3 over 3. That gives us 8 square roots of 3 over 3. There's 6 of these triangles, okay, within this main triangle. So 6 times 8 square roots of 3 over 3 is going to give us 16 square root of 3. So it checks out that way. That one's a little bit trickier problem, but it just is knowing 30, 60, 90. Okay. You'll encounter if it's 45, 45, 90. So just real quickly, if I have this diagonal from a square, all right, well, that's not the apothem, this is. Okay, well, I know that this is a right angle, and I know that this was 90 degrees, this line right here that goes to the corner, that's going to create a 45 degree angle, which means this is 45 degrees. Okay, and the hypotenuse is one side times the square root of 2. Okay, as I get a text message. I think that's the bell to end today's lesson.